Namaste, I am JVN Dr. Kiran Yadav. Welcome to the digital classes of JVWU Women's University. This class is for B.Sc B.Ed PCM second semester and B.Sc second semester. As discussed earlier in the previous lecture, we studied the formula for work transfer for different processes. There is another form of formulas which can be used for solving numericals, which are in case of isothermal process, we studied that the formula for work transfer is P1 V1 ln V2 upon V1. Here V1 is specific volume. We know the gas relation, that for in case of ideal gases the relation is P1 V1 is equals to RT1. Therefore in place of this P1 V1 we can write RT1. So the formula for work transfer becomes this. In numericals there is the value of temperature and V1 V2 are given, and you are asked to calculate the work transfer. In that case you need to use this formula, not this one. Okay, for polytropic process also the formula for work transfer was P1 V1 minus P2 V2 upon n minus 1. In case of P1 V1 we can write RT1, and in case of P2 V2 we can write RT2. So the formula for work transfer becomes RT1 minus RT2 upon n minus 1. Okay. Next topic is polytropic index. So we studied about polytropic processes. Any process which follows the relation PV is to power n equals to constant is known as polytropic process. Here this term n is known as polytropic index. We will calculate the value of this n. So on PV diagram I represented a thermodynamic system which goes from state 1 to state 2 through a polytropic path, which means this path satisfies the relation PVN is equals to C at each point. Okay, so at state 1 and at state 2 the ratio of P, the product of P and V is to power n will be same. So at point P it will be P1 V1 is to power n, and at point 2 state 2 it will be P2 V2 is to power n. These both will be same. Now we take log of these equations in both sides. So this equation becomes like this. Then we can write it as ln V1 plus ln V1 is to power n, because ln x into y is equal to ln x plus ln y. Okay, in RHS we can write like this. Then we know that ln x is to power y is equals to y ln x. So here this ln V1 is to power n becomes n ln V1, and this ln V2 is to power n becomes n ln V2. Next we take this term in the LHS, so it becomes ln P1 minus ln P2 is equals to, and we take these terms to RHS, so it becomes n ln V1 minus n ln V2. Okay, now as we know the formula ln x minus ln y can be written as ln x upon y. So here we write ln P1 upon P2 is equals to n ln V1 upon V2. From this the value of n comes out to be ln P1 upon P2 upon ln V1 upon V2. This is the value for n, which is known as polytropic index. Okay, so this is your formula. Next, first we will see the case of isobaric process. Okay, in isobaric process pressure is constant, so P is equals to C, where C is a constant. So in the formula PVN is equals to C, if we put n is equals to 0, okay, if we put n is equals to 0, then V is to power 0 will become 1, because x, we know the formula x is to power 0 is equals to 1. If 0 is in power of any quantity, then it becomes 1. So when putting n is equals to 0 in this formula, we get pressure is equals to constant. So in the formula for polytropic process, if we take the value of n is equals to 0, we get isobaric process in which pressure is constant. Okay, so we can say that for an isobaric process, the value of polytropic index is 0. There is another form of solving this. Uh, there is another form for solving this relation n is equals to 0. Like there is another method by which we can find this value in case of isobaric process. So which is, first we write the relation for polytropic process, which is PV is to power n is equals to C. At state 1, we know the value for this is P1 V1 n is equals to C, and at state 2 its value is P2 V2 n is equals to C. If we divide both these equations, then we get P1 P2 upon V1 upon V2 is to power n is equals to 1. And if we put here the value of n equal to 0, the value of n as 0, then V1 upon V2 is to power 0, and this term will become 1, because 0 in the power of any term equals to 1. We know that formula already. So it becomes P1 upon P2 is equals to 1, which means P1 equal to 1, which means pressure at state 1 is equal to pressure at state 2. So if pressure at both the states is equal, that means pressure is constant. That means the process is isobaric. So here from this derivation also we can say that in case of n is equals to 0, we get isobaric process, or we can say for isobaric process and value of n is 0.